centroid. And the centroid is created by the medians. Remember, the medians are the segments that connect a vertex with its opposite segment, but where? At the midpoint. Okay, and as you do or draw the three of them, so the centroid is the point of concurrency of the medians of the triangle. Okay, of the triangle. Important information, okay? You better keep it in mind. This is what I'm going to do. I'm going to hide the medians. Click on the median, click on this median, click on this median. I'm going to make the comments stay. This is important information. So now we have the four centers of the triangle, and I want you to do this. Just to review, okay, just keep an eye on the comments I made here. Okay, let me put them probably right here. Oh yes, so give me a sec. I'm going to fix this to make it visible to you, probably right here. Much better. Okay, look at this. So review. Circumcenter has been created by the perpendicular bisectors. Remember that the perpendicular bisector is a line that is intersecting, that is passing through each of the segments, and it is just going through or passing through right at the midpoint. And because of this, the point of concurrency of these three perpendicular bisectors is circumcenter, which in this case it's D. Then we have the incenter that is created by the angle bisectors. Remember that an angle bisector is a line that passes through the vertex, and it exactly divides each of these three angles by half. And as they concur, that point of concurrency is called the incenter. Then the orthocenter is the point of concurrency of the altitudes of the triangle. Remember, an altitude is a perpendicular line to each of the segments, but this one exactly passes through each of the vertices of the triangle, right? And that is called the orthocenter. And finally, the centroid. The centroid is created by the medians. How do I create a median? It's a segment that goes from a vertex to its opposite segment, from a vertex to its opposite segment, and it just connects it to the midpoint. When these points concur, the point of concurrency of the medians is called the centroid. Let's see something interesting about the centroid. I'm going to draw this segment from A to point I. As you can see, J, that is the centroid, is part of this segment. But I want you to notice this. We're going to measure this distance from A to J and then from J to I. And I want you to notice something. This is 3.44. Guess what? What do you think about this distance from J to A? I'm going to give you 1 or 2 seconds to think. How much do you think it is? How does it look like? Well, it is exactly twice as much. I'm going to drag this a little bit to try and have exact numbers. Okay, right here. Oh, sorry, it's not easy. Yeah, got it. Can you see? 3.5. So this is a very important characteristic of the median, okay? That as it passes through this, that is called the centroid, the distance, like this, from the vertex to the centroid is twice as much the distance from the centroid to the segment. That's what we have to, understand whenever we talk about the centroid and the medians, okay? Keep that in mind. I'm going to erase this. I don't need it. it seems like that for some reason I don't see the circumcenter. Did I hide it somehow? Or it seems like it disappeared. Oh my goodness, this is not good for my video because I'm not going to record this again, guys. So no problem, we're going to create it again. Yeah, okay, it disappeared, but we're going to create the circumcenter again. Perpendicular bisectors, pretty quick. Here, here, and here. Okay, and intersection. Cool. Point D. Now it's here. Okay, perfect. Now we have what we need. Okay, I'm going to make them invisible, and then we got it. Okay, now I want you to notice something. We're going to create a line here. As long as you choose 2 points, you are going to create a line. Let's begin with the first point of the line here at F. That is the orthocenter, for example. Look at this, orthocenter. And immediately you see that GeoGebra is waiting for me to click on a second point. Can be this one? No, I don't need it. Look at this. And this is very important, guys. Look at this. I'm going to put it in my notes that, oh, sorry. Important aspects here, important information, important facts. That, oh, I'm going to check which of the centers are part of this line. Can you see that F, orthocenter, J, centroid, and D, circumcenter, are collinear, are part of a line? Well, let me tell you, this is something very important. So, this is one of the first things we can say. Circumcenter, orthocenter, and actually probably I'm going to write it this way, the way we see it here in our picture. F is the orthocenter, then the centroid, and the circumcenter are collinear. Sorry, I don't remember if it is, I think it's just one L, so I'm going to keep it like that. So they are part of the same line. But part of the questions are going to be like this. Can you see that you can click, as you click and keep, you can drag it and you can make it move. Okay, you're going to experiment with this, all right? Because this is going to create interesting things for you guys. And just pay attention to that. But now you know how you can drag each of the vertices and move them. And well, you can, make some conclusions about this as you move each of these points. Remember, the one that is not part of this line is E. Can you see? It's not part of the line. It seems like it is independent. But I have some questions in the quiz, and you will have to drag this and see what happens, right? Look at this, look at this. Different types of triangles. Probably I don't want you to be distracted by GH or this. So you remember, now you can click on show and hide, and then you can click on G, point I, and point H as well. Click on the arrow, and then you just have the 4 centers in here. Okay? This is all I have to say. So you should be doing the same thing in your GeoGebra, because when you're done, this is what happens. You might want to write your name here using the text box, probably right here, and then you're going to write your name. Let's say, hey, my name is Omar Naranjo, and then period 4 or 6 or 8. Click here, and then you will see my name in here. And you probably want to create a screenshot, if you can create it in the Chromebooks, or you might want to click on the menu here, and probably you want to, there are 2 possibilities. You might want to download it as a PNG, so you will see just the picture, Yeah, export as a picture. You might want to write your name on it, Omar Naranjo Centers, for example, and then you say export, and it will immediately show me where you want me to, save it. So you're going to save it wherever you want. Yeah, you're going to save it wherever you want, and then what you're going to do is you're going to, well, I'm going to save it. For example, I'm going to download it as a PNG. It's like a picture. I'm going to say this is my name, Omar Naranjo Centers, and I'm going to export it. I'm going to save it in my computer here, and you save it, and then you are going to send me this picture to my email. I'm going to write my email here. Remember, my email is omarn@provo.edu. When you're done, this is what you're going to send to my email, please. Or remember, a screenshot and send me that picture. That's all I have to explain about the centers. And now, don't close this Geogebra file because you will have to use it in order to answer some of the questions that you see in this quiz of the day. All right. Thank you very much, guys. And that's all for